As you've heard, my name is Amy Null. It really is my surname, so please make sure your code accepts it. I cannot count how many times things have broken on it. And today we're going to be talking about rethinking application infrastructure in Elixir. So before we actually get into that, why not try this at home? It turns out that this is a really broad, really deep problem space. And there are plenty of companies that are built around handling just one aspect of it, much less all the things that I'm about to cover. So really broadly speaking, what is infrastructure? Infrastructure is everything that's not your application code. But that's not really the greatest definition of the world. So a bit more specifically, infrastructure is things like your container orchestrator, so Kubernetes, Nomad. It's your message queue, things like RabbitMQ, things like Nats. It's your host management tools like Ansible, Saltstack, Chef, Puppet, and I'm sure there's a host of them I'm forgetting. And it's also things like your database. You have Postgres and MySQL and MongoDB and Cassandra. And then all the more recent stuff like CockroachDB, stuff like Elasticsearch, so many different tools. And especially if you're doing microservices, you're going to be touching all of these. And so this kind of gets us into this idea that there are two main layers of your application. You have the actual app layer, which is what your users see. It changes fast, it changes often. Then there's your infrastructure layer. It changes slowly and rarely. So realistically, you might say, deploy your app 20 times in a week, but I will have some serious questions for you if you redeploy Postgres 20 times in a week. So when it comes to infrastructure and containers, it turns out that it's really hard to do, especially because containers are mortal and your database in particular isn't a fan of this whatsoever. A more elastic database like CockroachDB, Cassandra, probably Elasticsearch, they're going to be a lot more tolerant if a container disappears, but that's not the same as it being a great scenario. Additionally, having a on-disk volume for your database is hard, especially you have one Postgres instance, one volume. That's just a recipe for disaster. And of course, you can always fat finger a Helm uninstall Postgres and whoops, suddenly production's down. I have done all of these at some point, would not recommend it whatsoever. So really broadly speaking, in this infrastructure space, we have a couple of the big elephants in the room for the dev tooling around it. We have Kubernetes. Kube is awesome. I've used it a bunch. It supports literally everything. Massive community, widely used, widely tested. Everyone uses it. It's really great in those ways, but it's also really hard and not so great. You have YAML for configuration, which is either you love it, you hate it, probably somewhere in between. Everyone I know has had at least one complaint. Then you get into having to deal with templating, like Helm or KSonnet or whatever else. There's also just so much to remember with Kube because it tries to support everything. That leads into you have to know all the different switches to try and make it do what you want. And then especially tooling around Kube is really hard. You can see just from the ecosystem how many tools there are, which kind of gives you the feeling that wow, this is really big and complicated. And of course, you have the nightmare scenario of if your cluster breaks. I have been in this situation before, and it is terrifying when you Google the error message you get and the only search results are, hey, this is the Kube source code, good luck. It's not a great scenario to be in. So beyond that, we have our messaging elephants, so to speak. We have RabbitMQ, Nats, there's more stuff like Kafka. There are so many. So I'm just gonna touch on these two. They are really great. Again, they're widely used, lots of support, lots of companies backing them. They're also really good at being really fast. And they let you do message routing, but it's relatively simple, I guess would be the way to put it. You have Nats, which lets you can route on a subject. You can wildcard match on those subjects for your subscriptions, and then it's just pub sub on them. RabbitMQ gets a bit more complicated. You have messages which get sent to an exchange. The exchange can then figure out how to send it to a queue. So you have your direct exchange, which sends it. A message comes in, it goes to the queue at request. You have the topic exchange. Your message comes in, it can get sent to a wildcard match. You have the fan out exchange where you send a message and it gets fanned out to a set of queues. And finally, you have the headers exchange, which is the most powerful one of all of these. When you send a message to RabbitMQ, you can put headers on your message, and then the headers exchange can look at it, find queues that match those headers, and then route your message to each of them. And that's something really powerful, and we're going to be coming back to this general idea later on. So finally, we also have your tooling like Ansible and Saltstack. There's so many more of these, but there's only so much time to get into them. So they're all really wonderful tools. Again, you have Ansible, there's kind of like that YAML, you love it, you hate it. It works over SSH by default. You love it or you hate it, depending on your use cases. Like you want to be distributing SSH keys to all your production servers or something like that. And it kind of really gets back into that issue of like YAML templating, not a great time. You have Saltstack, which is a different approach than Ansible, where you stand up a master or multiple master servers, you can get high availability. And then you have your Salt minions that run on your individual hosts. They talk back and forth over 0MQ. And Saltstack is configured with the YAML by default, but you can use basically any config language under the sun. It's really powerful like that. It's a really cool tool. So what does this all kind of look like in a typical application that might be using these tools? So consider if you're making like a chat application, so Slack or Discord. You have to send messages in real time. You have to persist that data somewhere. Like you might have a web front end. You probably have some apps. You have to handle things like file uploads, so images and videos. And then what about things like voice or video calls? Those add a whole other level of complication into it. And so already you can kind of tell this is going to be spanning a bunch of different aspects of putting an app out there. So from a more infrastructure perspective, well, from what your app looks like, it becomes, you have to send and receive messages. So say you might have a REST API to create them. You might push them via a WebSocket. You're probably, deploying them with Q. You have to persist your data. So you might be running databases and containers with volumes. You might be, say, just like using a SQL database or something else in the cloud. You have a web front end. Well, where are you going to deploy that? Is it going to go to Netlify, Vercel, Cloudflare Workers, any number of options? You also have things like file uploads. Those have to go to S3. You have things like voice and video calls. Those are going to need WebRTC servers. And so when you kind of put all this stuff together, it looks a little bit scary. And so this is just what you would think about for putting your app together. So you would also need to think about things like a media proxy so that people can't phish IPs, so you can strip bad content from a message. But then when you're trying to actually deploy all this stuff, well, you need to think about how am I getting it onto host machines? How are those going to be configured? What kind of machines are they going to live on? How are they going to be communicating? How are they going to handle things like file uploads? How are they going to persist data? And so all of these infrastructure concerns really start coming back into play with this, because not only do you have a complicated application to put out there, you also have to think about all the things that are supporting it. And really, when you start thinking about that, wow, that is a lot of tools that we have to deal with. So this adds in a lot of complexity, because as a developer, I don't really want to have to think much about this. And some of these tools are hidden well away. Like in my day-to-day, I'm probably not caring about how do I configure a host to have a package installed. But some of them are kind of still really in my face about it. So the obligatory one is Kubernetes, because you just have to know so much to even get a complicated deployment out the door. And like having to deal with the templating and all the tooling around it can be really painful. And so this kind of gets us into this idea of specifics versus semantics, where you describe what you want versus how you want it done. And tooling is more of the specifics, how you want it done, whereas being able to just throw a config file at anything and have it happen really is more of what you want to happen. And so some of these tools do get into this idea, like with Kubernetes, you give it a manifest of what you want in YAML, it stores that, and then it has a control loop that can make the state of the world resemble that. But even with that, we still have just so much that we would have to know to stand up all this stuff. So the burning question is, can we do better? Spoiler, I think we can, otherwise I wouldn't be here. So the kind of fundamental thing that all of these tools get into is this concept of IPC, moving a message from here to there. When I'm writing this kind of IPC stuff, I don't really want to think about how this message moves around. Like, sure, I could get into knowing like, hey, here's RabbitMQ versus Kafka versus insert however many other queues here, or here's how I do a REST API and proxy it with these tools, or here's how I pub sub something and fan it out with like Redis or something else. That's caring about the specifics of your transport layer. And I don't really want to have to do that. I just want to be able to throw code at something and have it figure it out for me for the most part. And so you might think this is really starting to sound like, hey, you're just writing a message queue or something. And so, I kind of did. It's called Singyeong. The name is Korean. It means nerves because it's kind of like the nerve center of your application. It's open source. There's a GitHub link if you're interested. It's still kind of alpha quality, mostly because it's just been my spare time hobby project. And so things that connect to it are, they all speak WebSockets because let's be real, basically every language can speak WebSockets. WebSocket transport is kind of the fastest thing to get going with. It supports JSON, ETF, or message pack, depending on your programming language. So if you're using Node.js, you probably want to use JSON, but if you're writing Elixir, you're probably going to be sending ETF. So it supports clustering, of course, because what use would it be if it didn't? Everyone needs clustering and high availability these days. So why would I make something new? Well, by implementing something new, I can make a custom protocol for it. That means I can have a clean slate. Instead of having to work with RabbitMQ to write a plugin or work with another message queue and fit into that worldview, I can make it do what I want exactly how I want it. It also lets me have a really simple server implementation, less than 5,000 lines of code. At the time that I put this talk together, it was at only about 3.6 thousand. I don't think it's moved much. And it can fit my wants and needs perfectly. So we have things like automatic clustering. You can just spin up nodes and they can find each other. You have client node separation, this idea that if a section of the cluster disappears, you won't have to worry about messages being routed somewhere that they can't reach because of how nodes are partitioned across, how clients are partitioned across nodes. And so it can kind of route messages all over. You can push a message to a single client, you can pub sub, you can queue messages, and you can also do HTTP proxying. And that last one kind of feels weird because, this is message queuing. How does that come in? So, excuse me, wrong slide. So HTTP proxying is kind of just a different view of those other things. They're all some form of get this message from here to there. HTTP is just happens to be synchronous, usually happens to be a specific protocol for doing it. It's just also incredibly common. So why reinvent the wheel? So routing in Singyeong is more than just, hey, send this to this service or send this to this queue. Instead, each client that connects to it can set metadata about itself. And this metadata is just JSON. You can just dump arbitrary JSON key values in. And so from this, you can say, when you're sending a message, you can just say how it wants to be routed. So the example is send this message to the API server with latency under 100 milliseconds and user ID 1234 is connected to it and selected by the minimum latency. So you can kind of bake into the message that you're sending certain invariants about what can receive it. And so this kind of makes really difficult problems become really easy. Suddenly service discovery isn't this horrible thing where you have to deal with DNS because that's always the problem, or you don't have to deal with looking up a service somewhere. You don't have to deal with failover or load balancing because all of this is just handled transparently for you on the server. You never have to think about one of these. All you have to say is get my message from here to there, and I want these invariants baked into the routing. And so metadata for this, it lives in amnesia. And I realized as I was putting this together, Singyeong is kind of the world's worst, quote unquote, key value store. Everyone kind of invents one of these at some point. As part of this, I wrote a match spec query DSL. Here's a GitHub link for it. It turns out that writing match specs is a not fun experience. So anything to make it easier made my life a lot easier. And so now when you're routing messages when you're trying to figure out where to route a message, all it has to do is query amnesia and call it a day. And so this comes back to that node client partitioning thing. Nodes only know about clients connected to them. Now, trying to route a message is just a really quick RPC across the cluster and you call it a day. It's also really simple because trying to query amnesia is only about 250 lines of code for all of this. And that's mostly just mapping operators into match specs. It really helps that amnesia is so powerful to work with. And so here's like an example of what a routing query might look like. You have like an application that you might want to route to, because clients that connect are partitioned by application ID and then their client ID within that application. And so you can specify like operations that you want to use to have your query run. You can say, hey, check if the value at this path in the client's metadata is less than or equal to this value or greater than or equal to, or the list contains, or this value matches the value at this other path, or so on. And you also have selectors like min, max, average to choose specifically, hey, send this to the client with minimum latency, or hey, send this to the client with the most users connected, or so on. And there's so many other features that this kind of gets into, like you can have queries that are optional, so that if it doesn't match, just ignore the query, send it to any client. Your messages can choose to be droppable. If a query doesn't match, drop a message. You get consistent hashing, so you can specify a hash key, and as long as your query result is the same, your message will always go to the same client. And there's also like the concept of comparing paths that I just touched on, so you could say, check if path/key is equal to path/key2, kind of a thing. And so many more things that I would not have been able to fit it all in here. And so this is a really, really, really powerful building block that you have, because you can really easily do a lot of stuff with this. You can do like container scheduling, and you can do it really, really fast, because again, it's just send a message to the server, to the connected client that can schedule a container like this. You can do all sorts of really complicated inter-service messaging. You could use it as an HTTP ingress. You can say, hey, send this HTTP request to a service that can accept from host XYZ. You can store documentation, because that's just arbitrary JSON, it's just metadata. And you can do things like host management. So you can say, hey, send this to a node that doesn't have this package installed so it can install it. There's so many other things that you can do. And so I did. And so this gets into this project called Mahou, which means magic. It's open source microservice infrastructure, basically. The name means magic because that's kind of what it's trying to be. It's still really prototype phase. So like it technically works, but you would never use this in production, kind of a thing. And so it contains like the really basics of like a container scheduler, an HTTP ingress at some point, documentation generation, a command line interface, and a bunch of other stuff. And this kind of gets really broad, really in depth. And so if you go back to that app versus infrastructure layer we had talked about, Mahou focuses on supporting the app layer. If you need a database, I'm sure your cloud provider is happy to sell it to you. For now, I might try and go back, target that more infrastructure-y layer. But for now, that was much too complicated to even try to support. And so this kind of gets into this idea of specifics versus semantics again. The goal is that Mahou can hide the specifics of things like message transport, how your container gets scheduled, and your code can just think about it. And so this uses Singyeong under the hood. It's why it's required for it. And there's this blog post I had written here that's kind of related about how like inter-service messaging can be kind of painful. Here's what might this look like in the future? And it's kind of the ideas that I've been digging into with this project. And so like, as the name implies, it tries to be magical. It like really fast container scheduling, service discovery, load balancing, failover, IPC are all baked in. Deployments are really simple. Documentation's automatic. Someday it'd be nice to have like automatic SSL. And so when you're kind of dealing with stuff, configuration looks really familiar. This is an Elixir project, might as well use Elixir to configure it. All you have to do is just like a basic use statement, add an abstract as a manifest or like a list of them. And they describe like what your app is and the limits on it. And you just run a command to deploy it. I a bit cheekily called the CLI tool wand, because magic wand, it kind of makes sense. So configuration is just plain Elixir. You just put in a struct. You can get away with not specifying most of this. Real like namespace will default to something sane if it's not specified, and environment is optional, of course. Inner port is only really needed for port binds, like if you're planning on exposing a web service. It'll be nice to not need that someday. I've been working on it, not having a great solution yet. Limits are required because my goal is that by specifying these limits, you can say how efficiently you want machines packed. So it can reschedule your applications at runtime to make sure that things are packed as efficiently as they can be. And it also like prevents overcommitting your container resources. You can't choose your external port bind because Singyeong needs to know the IP and port to do HTTP proxying. And so if you can specify your internal port, you can then use that to automatically bind to a random external port. Namespacing, again, is optional. It just goes into a default namespace. Ideally, I wouldn't need any of this. That's my goal. We're not there yet, obviously. I'm hoping maybe soon. No idea on when that's going to happen, unfortunately. And so one of the main goals here is dealing with that IPC concept, trying to make the transport layer completely transparent. Right now, we're not really there. So for an example, this is the code from the CLI tool that creates and deploys a container. It's not beautiful, it works, but it's still not quite as good as I want it to be. Because, you know, the transport, how it's being sent, that specifics, I don't want to have to think about that. I want to write my app, not care about, or the infrastructure level things, not care about the transport. So maybe someday it might look more like this, where I could just say IPC.send message and everything's automatically figured out. Maybe I can provide a couple options. So like, if I want to await a response, maybe it's sent as an HTTP request. If I want to broadcast it to all things, I can just put in a config option for it. If I wanted queued, I just say the queue name and so on. And the idea is that all of this can be more or less transparently handled through the same interface. And so Mahou also kind of tries to handle the issue of documentation, because you can generate most, if not all of it, from code, and you can just store it as metadata in Singyeong. And this is actually really useful to have, because once you have it stored there, you can route on it. You can say, send this message to a service that accepts message ID 123, that accepts this message kind at version 123. And so now you can guarantee that whenever you're sending a message, it will go to something that can handle it, or you'll get an error back. And so when you're generating this documentation, at least in the Elixir world, it just literally use one line of code, use mahou.docs. It uses like the type specs and stuff in your code to generate them. I wrote a library for it because it didn't really seem to exist. So Peak exists to look at your code and extract type information and turn it into JSON-friendly values. I haven't written a doc viewer yet. It's still iffy. I'm not 100% settled on like the format that this data actually gets stored in. And so here's what it looks like. Super simple. This is just an example Phoenix controller. You can see it's like 3 extra lines of code. Use mahou.docs and then annotate your controller functions with just inputs and outputs. Ideally, that wouldn't be necessary, and you can just write a type spec. I'm not there yet. And that's it. Once you have this, all of that metadata, like the types of your structs are automatically discovered, turned into JSON. It's all stored for you. You never have to think about it. And stuff like your doc strings that you write, that's all grabbed automatically. It's never, ever something you even have to think about. And so like, again, it kind of lets you ensure those invariants almost about the messages that you send. You can assert that the types are always going to be correct. The message versions will always match up. And now that your documentation's all in one place, suddenly it's really easy to get an overview of the entire system. There's no more lies in your documentation because it's automatic. It's always up to date. And so now your external docs that end users might see from this service, it's only as good as your internal docs, the docs in your code, because one comes from the other. And so it just kind of falls out neatly that these things work together really well. And so this is just a really quick look at like the architecture of this thing. Everything talks over Singyeong. The names are all just a bunch of weird jokes that came up, like the host daemon. The name of it is the Korean word for daemon or demon, so it kind of makes sense. The ingress name is just because shoujo is Japanese for girl, and I kind of wanted to work in the obligatory magical girl joke here, and so on. So it's basically just everything talks to Singyeong to make it work. The CLI talks to it to get to the scheduler. The scheduler talks to it to get to the host daemon, which can actually schedule containers. The ingress talks to it to get to the app containers. The app containers talk to it so that they can send their own messages back and forth. And also the autodoc talks to it to pull out that metadata about documentation. So you can really see how this one building block of a tool becomes really, really important, really powerful to have when all of this can easily be built on it. Like if you look at the code that I've written for some of this stuff, most of the host daemon, I think, is just writing a basic Docker client and not even like worrying about any of the other stuff because that's all handled for me already. So again, like everything only talks to Singyeong because that means I can enforce certain aspects of it. And besides that, we just kind of lean on cloud provider infra. They provide private networks for you. They provide databases. They provide so much stuff. Well, why am I reinventing that? Why can't I just use what they give me? Again, someday it would be cool to be able to like support this stuff. Don't know if I'm going to reach that even like this year. So why would I make this? It's kind of just like an exploration into what things might be, not just incrementing on what we have the way tools like Kubernetes have. And the goal is also just kind of trying to reduce complexity in what I as a developer have to see. If I can write little to no config, suddenly, hey, it's a really convenient thing for me when I can just be like, run the up command and my code is automatically deployed everywhere. Everything that the system needs to know can be figured out automatically. It's also just kind of built out of frustration with insert tool here because there's a lot of those. Like DNS failing on me has been a pain in the past, so that's why Singyeong exists. It lets me work around DNS failing. YAML has been frustrating in the past with like how it automatically converts values between types silently. So just using plain Elixir for it means that things like types are more easily asserted. That's frustration with things like Kubernetes, with how complicated it can be to configure, or how scary it is when something breaks. Instead, I can just use my own tooling that I've been writing here that can do things really easily. And it's also just, you know, a world of pure Elixir infrastructure sounds nice. It's a great language that makes sense for this kind of stuff because things like hosts are effectively just a gen server inside the Singyeong server. Things like your CLI is also just a gen server. Everything connected to it is just a gen server effectively. And so this is a really elegant model to have with it because now everything just, it just makes sense that sending a message to a host is effectively just the same as send a message to a gen server, but with a bit more abstraction. And so like future work in this area, it would be nice to manage the full infrastructure layer. I don't know if I'm there yet. I don't know if I will be. It would be nice to have smarter container resource limits. Like I don't want to have to specify that in a config. So I would love to be able to just have it automatically figured out at runtime. Not using Docker would be nice for some properties that I'd like to get. So maybe I might switch to containerd. I've been working with a friend on this idea of a new container runtime. That's their Twitter handle if you're interested. The general idea is like, I don't want to have to think about building an image. I don't want to have to think about how big that image is. Ideally, I can just build my static binary, push it to S3 and call it a day. And then when it runs on the host can pull it down, figure out which SDKs, quote unquote, it needs, and just stitch the image together dynamically. So if you need to have like a Node.js app running, you push a tarball of your source up and probably your dependencies too. The server can then just pull it, start from an Alpine base layer in the Node SDK and keep going from there. It's like Flatpak, but for servers ideally. And also I just kind of want really fast container starts, ideally sub 100 milliseconds. I'm not 100% sure if we can get there. It would be great, but especially after like trying to layer in SDKs, it might not get there. But you know, that's the point of it being future work. We'll see. And yeah, that's all I've got. Time for questions.
That's great. A fantastic presentation, Amy. And we have a lot of questions. So what I'm going to do is launch right in. Yeah, I'm going to go in order of vote. So I know some people have asked multiple questions, but I'll go in order of the voting that Huva gives me. So first we have Dayanand. Can you unmute and ask your question?
Yeah, basically, I think this whole presentation was kind of hitting home for me. I'd always, wondered that given the supervision, capabilities and just the isolation and all that stuff, Beam is a great candidate for creating a tool that replaces Kubernetes, which is highly complex, and even Nomad, which is comparatively lesser, complex, but an orchestration layer can be easily built with it. And I think what Amy did here is basically, create the foundation or like an alternative, solution. So this is great. I was trying to come up with some kind of, a DSL around, specifying, I think, with Amy's work. I think that is, already done, but I would like to hear more about it. Like, is there anything else that is missing from that Nomad or Kubernetes are providing that we are not thinking that can be done in Beam?
A lot of it is just mostly like the container runtime or dealing with syscalls, dealing with things like a networking, firewalling. Those aren't really fun to deal with either way, but the tooling in the Beam world just doesn't really exist. Like, yeah, you can just call out to IP tables or call out to the Docker CLI. That's not a great solution to it. We would have to have like actual native APIs for it, and we're not really there. I think like the Beam does make sense for doing some of this stuff, but that's not the same as it being ready for it.
Great, thank you. The next question is from Isaac. Isaac, can you unmute and ask your question?
Hi, sorry, the coffee machine is operating in the background. Can you hear me?
Yeah.
Okay, yeah, so my question, so a little bit of background. I actually implemented a much worse container orchestrator in Elixir for an R&D job a while back, and also have done a slightly still worse than what you have, VM orchestrator in Elixir that went out to prod. So I really appreciate the work that you've done, and it's quite amazing. So my question is, what sort of distributed consistency guarantees do you support over the cluster? And is it like designed in such a way that you could maybe choose a different one if one were available?
So right now in Singyeong, what it supports is most of the data tries to live local to the node where it's relevant. So things like client metadata are local to that client, the node that client is connected to. The only thing that has any actual distributed consistency issues is message queuing, and they all live in Raft using the Raft fleet library. So as long as that works well, it should be more or less as consistent as it can be. It would be nice maybe like someday to have like Delta CRDT support, for example, but it's just not been a priority for me.
Thank you very much.
Yeah.
That's great. Next on the list is you again, Daya. Do you have an additional question? Yeah.
Okay, right. Yeah, thank you. It was more coming from like I moved away from microservices world, and when I started working with Elixir, I was like, well, wait a minute. I mean, there's so much that I can do within a Beam application or monolith. I just wanted to hear your thoughts on it. Like, what is your opinion around it?
I think that the beauty of the Beam is that you can write your code as though it's microservices while keeping it monolithic. And then that way, as your application grows, you can profile, you can see what's taking long, what would make sense to split out, and then work slowly from there rather than trying to do that all immediately. And especially if you join things into a cluster, it's literally just writing the exact same code almost. Elixir works well for microservices, especially in cases where like you would need to have a cluster of them, but at least in my opinion, it definitely makes a lot more sense to start out monolithic.
Okay, thanks.
Daya, do you also want to ask about K8?
Right. So I think one of the things that I've tried to do is remove this extra layer that is the container runtime and try to just run it on like a native app without any containerization. So have you given some thoughts about that kind of a deployment and like how does are there toolings that you're trying to build around that? Because containers are great, but majority of time, do you really need them? That is a bigger thing for me.
It really depends on your specific use case. Like whether or not containers are needed, it depends on like, am I running like a Node.js app where everything is a separate file? Or am I running like Go where it can all be a static binary? How you deploy that depends on like, what kind of code are you writing? How are you thinking about how it's going to be managed on the server? And looking at like your specific question about databases on Cube, I personally say don't do it because every time I have, there's come to the point where Cube has lost the volume for me. I would not recommend it without very good backups personally. Then again, maybe I've done something wrong and people have surely had better experiences than I have. So please don't take my word as law on this.
Yeah, we use RDS. We started with Cockroach DB, but even that was tough for us to manage in even with Nomad.
Right. This is kind of why I'm trying to not support that stuff right now in my projects. I think it is a very difficult problem that people a lot smarter than me have already solved for us.
Great, thank you. And then another question that moved up the list, Zaki, are you available to unmute?
Yeah, hey, great presentation. So I was thinking really around, like I'm sort of new to the world, but as I started, like our application, we've sort of built out a micro front end, right? Where, like we're in e-commerce. So we've got, let's say, a product search. And so we got the front end guys for the product search and the back end guys working with the database for the product search. And we've got the product category. Then we have the cart checkout, and then we have the payment, right? And so in this kind of architecture and then looking at Elixir, and we're a complete Elixir and Phoenix shop, what would you recommend, how we can do? And my question was really around, could I use Zookeeper? But then I realized you created your own version of it. And so, like what advice would you give someone like a team like ours? Yeah.
My advice to like the Elixir world of Zookeeper, from my research, good luck. You have to use like Zookeeper XED or something. Yeah. Again, it's not really a world where the tooling exists, unfortunately. It's something I would like to see. I've tinkered with it in my own time. I wrote a very basic time traveling quote unquote key value store on top of React Core. I was probably going to turn it into Delta CRDT at some point. I'm not sure, but either way, it's one of those things where I'm going to tell you, please use the tooling that exists. Don't roll it yourself.
Okay, thanks for, I didn't have to walk off the ledge here. All right.